Hello and welcome to Physics Teacher. In this grade 12 chemistry tutorial, I'm going to go over Le Chatelier's principle, which is part of the equilibrium unit that my students would really like this tutorial for. So let's go over this. Let's start with some basics. Let's say we have some equilibrium. So we have substance A and B is in equilibrium with substance C. So very basic. And these are all gases. Okay. So what is exactly equilibrium? So you can imagine we have this graph, and this is going to be concentration, and this one over here is going to be time. So what it means is that A and B combine to form C at the same rate that C combines or breaks apart to form A and B. So the rates are the same, meaning their concentrations are constant. It doesn't mean the concentrations are equal. So for example, I could have over here, we can have a concentration for a substance A, and then here a concentration for B, and maybe over here a concentration for C. So you can notice all the concentrations are different, but they're not changing. All right, so what's Le Chatelier's principle? So a couple things can change equilibrium. One thing that can change equilibrium is if we were to add or remove either some products or some reactants. So add or remove products or reactants. So for example, let's say right at this time, I decided to add substance A. So what happens? We get a little bit of a spike here because I added some substance A. So this is going to shift equilibrium. Because I have more of A, there are going to be more collisions now between A and B. They'll be more frequent, and therefore we're going to produce more products. So C is slowly going to increase a bit until it reaches some new equilibrium position. Okay, because C increases, A and B are going to decrease. Right? And this is just for example, until each of them reach some new equilibrium. So that's one thing that can happen. So you can see all of our concentrations have now shifted to this new equilibrium position. So what else can happen? Another thing Le Chatelier says can happen is we can change the pressure. Now, how do we change the pressure? Well, these are all gases, so they're in some sort of container. If we decrease the volume, the pressure is going to increase, and vice versa. So what would happen if, for example, we increase the pressure? So how do you increase the pressure? You decrease the volume. And if you remember, concentration is moles per unit volume. Now the amount of moles isn't changing. That's number one. Volume is going to be decreasing, right? So if you're decreasing the volume, not only are you increasing pressure, but you're increasing concentration. So what's going to happen here is we're going to get a vertical spike for all of our substances. Like, let me just change the color of the last one so it doesn't overlap there. Vertical spike for all of the substances. Okay, well, then what's going to happen? Well, if pressure increases, what it wants to do is it wants to take up less space because it has less space. So notice here we have 1 mole of substance A, 1 mole of B, and 1 mole of C. So if A and B combined to form C, it would take up less space, right? So what we want to do is favor the direction of the reaction that gives us less molecules. So in this case, for this example, we increase pressure. We're going to favor a forward reaction. So if we favor a forward reaction, our product is going to increase. So that's going to go up. Okay, what about our reactants? They will decrease. So they'll each go down like so. And so now at some point in time, they will reach some new equilibrium concentration. Now there's one more thing that can happen, and that is a temperature change. So we can increase or decrease the temperature. So for example, what happens if we decrease the temperature? Okay, now let's say this example here is an exothermic reaction. So let me add some energy term in here with the products. Okay, now endothermic reactions require energy from the surroundings. So if I decrease the temperature, what I've essentially done is I've given less energy to the surroundings for those endothermic reactions. So if temperature decreases, we end up favoring the exothermic reaction. Okay? And in this case, that is our forward reaction. So when we decrease the temperature, all of these are going to favor our forward reaction. So we will increase in our product C. So we increase our product C, and B and A will decrease, like so, until they reach some sort of new equilibrium concentrations. So if you're looking at them, a quick and easy way to spot either 1, 2, or 3 is when we add or remove a product, we see a spike for one of our substances. If it's a pressure change, we are going to see a spike for 1, 2, 3, all of our substances. And if we don't see any spike, but rather a gradual change in all of our concentration, well, that was because we changed the temperature. All right, so that's the basic idea behind Le Chatelier's principle. One other thing I would like to mention, if you had an example of, say, A plus B is in equilibrium with C plus D, notice that the number of moles or molecules on our reactants is the same for our products. If it's the same in both ends, then pressure will have no effect on our equilibrium position. But I told my students I would not give them an example like that. So let's move on and try an example. So in this example, we have an equilibrium between nitrogen, hydrogen, and ammonia, and we have an exothermic reaction. We need to figure out what happened at these 3 times, T1, T2, and T3. So if we look at T1, we notice a spike, just a single spike right there in nitrogen. So therefore, at T1, what happened? We add N2. Okay, so we added some of the reactant. If we add some of the reactant, then this is going to be a forward favored reaction. Forward favored. Okay, and we should get more ammonia. So if we can check, we can look and see, and you'll see that ammonia does, right here, start to increase. So that is what happens, and both of our reactants start to decrease. Okay, so you can see, therefore, yes, we definitely added it, and so we had a forward favored. All right, let's look at T2. T2, we have 1, 2, 3 spikes straight up. That means pressure change. Okay, but was pressure increased or decreased? Since the concentrations are all increasing, pressure would have needed to increase, right? And it increases by lowering the volume that these gases are in. So therefore, what's it going to prefer? It's going to prefer the direction of less moles. So in our reactants, we have 4 total moles, and in our products, we have 2. So we have less molecules in our products. Therefore, this is going to be a forward favored reaction. And we can look at that too, because if it's forward favored, once again, we should get more ammonia. So let's follow our ammonia curve, and indeed that increases. whereas nitrogen and hydrogen decrease. So definitely forward favored. We're good on that one. Let's look at T3. T3, we don't see any spikes. Everything's gradual. So that is our temperature change. But did temperature increase or decrease? Well, this is an exothermic reaction. And if we look, here's nitrogen. So nitrogen increases. So nitrogen increased. And hydrogen, we follow hydrogen also increased. But ammonia decreased. So clearly, this is a reverse favored reaction. So reverse favor. So because it's favoring the reverse, the forward reaction is exothermic, therefore the reverse reaction is endothermic. And if it's favoring endothermic, it means we've given more energy to the surrounding environment. So temperature must have increased. Is everyone following along? Kind of getting the hang of this now? Let's try one more, see how we do. All right, so here we have another reaction. Looks like everything starts off in equilibrium. Something happens at 4 minutes, 10 minutes, and 14 minutes. Let's look at each one. At 4 minutes, so at 4 minutes, we have a gradual change for everything. Therefore, something happened to the temperature. Now, we don't have our energy term right here inside of the reaction. We have it over here. Right? It tells us our enthalpy change, which is positive. Therefore, this is an endothermic reaction. And here we have chlorine and carbon monoxide increasing. So we are getting an increase in our products and a decrease in our reactants. So this is clearly forward favored. Forward favored. And since the forward reaction is endothermic, that means our temperature has increased if we are favoring the endothermic reaction. All right, now let's look at 10 minutes. Something happened at 10 minutes. What happens at 10 minutes? Looks like we have an immediately spike, a drop of carbon monoxide. And so just one spike means something was added or removed. Now it's the carbon monoxide, and since the concentration decreased, we clearly removed carbon monoxide. All right, so if we removed carbon monoxide, we have less products, so it's going to want to make more. It's going to be forward, right? So we're going to be, again, forward favored. And we can double check that by looking at the graph. So it looks like chlorine increases as well as carbon monoxide, whereas our reactant decreased. So indeed, it was forward favored. Last one, at 14 minutes. What happens at 14 minutes? We get a drop in the concentrations of everything. So something happened with pressure. Now, because everything dropped, right? If all of our concentrations are dropping, volume must have increased. If we increase volume, we lowered the pressure. So in this case, all the concentrations dropped, therefore the pressure dropped. Okay, well, if all the pressure dropped, what's going to happen is it's not going to favor less molecules, it's going to favor more molecules. And we clearly have more molecules in our products than we do in our reactants. So this is again going to be forward favored. And we can look at the graph to test, see if we were right. And it looks like chlorine and carbon monoxide increase. So our products do increase, whereas our reactant decreases. So indeed, we are right. Okay, I hope everyone enjoyed that. I will be releasing a more detailed tutorial for all things on the equilibrium unit, but I wanted to do a specialized tutorial just for Le Chatelier's principle. If you have any questions, let me know in the comments, and don't forget to like and subscribe. Thank you.